Hey there. We have one more operation to talk about, and it's new in terms of its name, but we've done it before in Unit 6 when we were evaluating functions and we were plugging in variable expressions. So now we're going to define this operation called composite function. We're going to understand the notation and the symbolism. I'm going to read this as we see it. The notation, this is read f of g of x. I'm going to read it one more time. F of g of x. This version down here, and we do the in a different direction, is g of f of x. G of f of x. And we're going to figure out what that means, and then we're going to use it to create composite functions. All right, so what is a composite function? Well, do you remember back in Unit 6 when we were evaluating? We actually did synthetic division when we had a number, but when we had a letter, we were evaluating a function using another algebraic expression. What we did was we said, well, if f of x is equal to 3x plus 1, find f of a squared, right? So we said, okay, well, let's find f of a squared. It says wherever there is an x over here, I'm going to plug in a squared. So I have 3. Oh, hey, there's an x. So what am I going to plug in? A squared plus 1. And so f of a squared equaled 3a squared plus 1. That was a composite function because what you're doing is you're substituting. A function is substituted into another function, and we're actually creating a third function. Okay, so you have one function being substituted into a second function, and we're creating a third function. So the hardest thing to understand is the notation, so I'm going to read it again. This first one is read f of g of x. F of g of x. And it says that I'm going to substitute g into f. Substitute g into f. I like to write it in this notation because it tells me plug g of x into f of x, or evaluate f at g. Okay? The other way we can read this and set up problems is to go the other way, which is g of f of x. It's read g of f of x. G of f of x. And here we're actually substituting the function f into g. All right, so you can think of it as f gets plugged into g. F gets plugged into g, or we're evaluating g at the expression of f of x. Okay? So a lot of times it's good to put a visual with it, and you can think of this kind of as a conveyor belt. Okay? So basically, a function is evaluated and it produces an output. Okay? So you have an input to one function. That generates an output, and that output is then the input to the other one. Okay, you just have to be careful of the order. So if we have f of x equals 3x plus 1, and we have a second function, g of x is equal to x squared, and let's just say that we wanted to find g of f of 4. Okay, we could write it as g bracket f of 4. What this says is take 4 and plug it into f. Then take that answer and plug it into G. So let's do that real quick here, okay? So G of f of 4 says take 4, that's that number right there, and plug it into f. So I'm going to evaluate f at 4, and that's going to give me 3 times 4 plus 1. So that gives me 12 plus 1, which is equal to 13. Now watch, I take that 13 and it keeps moving forward, and in the next rule it says take 13 and plug it into G. So now I'm going to find G of 13. So that's going to be 13 squared, which equals 169. So G of f of 4 equals 169. And you can think of it as an ordered pair. My original input was 4, and my final output was 169. So it would be 4, 169. We can go the other way as well. We can find f of G of 4. The other way to write it is, you say it the same way, it just is a nested version, f of G of 4. I'm going to take 4 and I'm going to plug it in to G. So G of 4 is going to equal 4 squared, which equals 16. And then I'm going to use 16 and I'm going to plug that into f. And that's going to give me 3 times 16 plus 1. So that's going to give me 48 plus 1 equals 49. And that's my output. Okay? So G, or f of G of 4 equals 49. My original input was 4. My final output is 49. Okay? So you notice that I have this inner and this outer. You see how when we write it in the nested version, f is on the inside of the bracket, that's your inner, and then the one on the outside of the bracket, that's your outer. Okay? So now let's try a couple of these, and I want you to make a little bit note of a change right here. Instead of writing this as G of f of G of x, I want you to write it as f of G of 3, okay? And this is what we're going to find. We're going to find f of G of 3. So the first thing I have to do is I have to find G of 3. So that's going to be 3 minus 6 equals negative 3, because this is my G function over here, okay? Now I'm going to take this negative 3 and I'm going to plug it into f. So f of negative 3 is equal to negative 3 squared plus 2. That's 9 plus 2, so that equals 11. So f of G of 3 is equal to 11. So my ordered pair is 3, 11. Let's try it with the next one. G of f of x. Also written like in a nested version. The f, actually we want to do this at 0. Let's cross that out and put in a 0. Cross that out. Seriously? Come on, folks. And put in a 0. So the first thing you're going to do is you're going to find f of 0. I just think I might scream. So find f of 0 first, because that's my inner function, my inner rule. And so I'm going to take 0 and I'm going to square it and I'm going to add 2 to it, and that gives me 2. Now take this number and plug it into G. So g of 2 is equal to 2 minus 6, which is equal to negative 4. So g of f of 0 is equal to negative 4 for the ordered pair 0, negative 4. And we can also plug a number into the same function or rule more than once, like in example 3. This says find g of x. So you start here, and we're going to do it at negative 3, so cross that out and put in a negative 3. And so let's find g of negative 3. Well, we get negative 3 minus 6, so that equals negative 9. Now take this and plug it into g of x again. So g of negative 9 equals negative 9 minus 6 equals negative 15. So g of negative 3 is equal to negative 15, and I get the ordered pair negative 3 comma negative 15. All right, we can also do this with ordered pairs. All right, and the thing to remember is that your first coordinates, those are all of your inputs, and your second coordinates are all outputs. Input, output, input, output, input, output, input, output, input, output, input, output, input, output. We want to find f of g of x. All right, so for every input in G, we're going to find its output and then trace it back into F. All right, so we're going to go f of g of 8. So let's find it. Well, here's 8, and here is the output, right? So g of 8 is equal to 15. Now we're going to look for f of 15. So that's f of 1, f of 0, f of 15. Oh, there's 15. What's its output? 11. So we're going to get the ordered pair, original input 8, final output 11. Okay, now we're going to do f of g of 5. So we're going to look for the input of 5. That gives us a 1. That's my output. Now I'm going to take that output and I'm going to plug it in and look for it in F. Oh, there it is right there. And that gives me an 8. So that means my original input was 5. My final output is 8. Now I'm going to do it with the next input in G. That's 10. So G of 10 is 14. I plug in a 10, I get out a 14. Now I go into F and I look for a 14. Do I see one? Well, here's 1, here's 0, here's 15, here's 13. There is no 14 as an input into F, so this does not exist. All right, now we're going to try f of g of 9. We're going to look for the input of 9, and the input of 9 in G gives us an output of 0. Okay, now I'm going to look in F and I'm going to plug 0 into F and see what I get as my output. Well, that's a 5. So I get 9, comma 5. Sometimes you can have whole functions that don't exist. Okay. All right. So let's work through the top 4 together, and then you're going to work through the bottom 4 as part of your video questions, okay? So I'm looking to find f of g of x, okay? So that means I'm going to start in with g, and I'm going to then trace it back into 4. So f of g of 4, that's my first input. G of 4 is equal to 3. And then f of 3 is equal to negative 2. So my first ordered pair is 4, negative 2. I plugged in a 4 originally, and I got out a negative 2. Now I'm going to move to my second input in G, which is negative 2. So G of negative 2, my output is a negative 1. So G of negative 2 equals negative 1. F of negative 1 is equal to, and here's negative 1 in F, so now I'm going to, so its output is negative 5. So I get the ordered pair, negative 2, negative 5. Right? Now I'm going to do the next input for G, which is 9. G of 9 is equal to 4. F of 4, well, that's 3, negative 1. Oh, here's 4, and I get an output of 7. So I plug in a 9, and I get out a 7. Right? Again, we're going to find G of 3. G of 3 is equal to 10. And now I'm going to find 10 as an input in F. So F of 10 is equal to 8. So I get, my original input was 3. My final output is 8. And that is the set of ordered pairs for F of G of X, these 4 ordered pairs. You won't always get 4. It just varies. Some composite functions don't exist at all. So here are your 4. It's going the other way. You're going to find F of 3 and then trace that into G. Then you're going to find F of 1, and then you're going to trace that into G. F of 4, and then F of 10. All right? So you go ahead and do these for your video questions, and then come back and see how you did. All right, F of 3. My input is 3. My output is negative 2. So G of negative 2. Okay, here's G, here's negative 2 is equal to negative 1. So I'm going to get the original, or I'm going to get the ordered pair, 3, negative 1. Now I'm going to move to my next input of F, and that's negative 1. F of negative 1 is equal to negative 5. Now I'm going to look for F of negative 5 in G. Here's a 4, a negative 2, a 9, and a 3. G of negative 5 does not exist. Now I'm going to check the next input for F, which is 4. F of 4 is equal to 7. G of 7, well, here's a 4, here's a negative 2, here's a 9, here's a 3. Doesn't exist. F of 10 for number 4 is equal to 8. G of 8, 4, negative 2, 9, 3. There is no G of 8. Does not exist. So the only ordered pair for this G of F function is 3, negative 1. All right, I'm going to have you stop the video, and that's all I want you to do for tonight, and then we'll come back for the second part. All right, so now we're going to move on to composite functions, where we're actually plugging functions into other functions. All right, it works the same way. I have these two functions, f of a, which is 2a minus 5, and then I have g of a, which is 4a squared, and I want to find f of g of a. So that means I'm going to plug g of a into f. G of a is my inner one, and then I'm going to plug it into f. So basically I'm finding f of 4a squared. Why? Because g of a equals 4a squared. So I get 2 times 4a squared minus 5. That gives me 8a squared minus 5. That's f of g of a. I'm plugging one function into the other. I can also go the other way. G of f of a. We can write it nested. G of f of a. So f of a is equal to 2a minus 5. So I take out the f of a here and I put in 2a minus 5. Why? Because that's what f of a equals. And I'm going to plug that into g of a. So I have 4, and then I have an a. Oh, there it is. 2a minus 5, and then I have to square it. This is a binomial, so we have to expand that. So that's 2a minus 5 times 2a minus 5. And I get 4a squared minus 10a, which is negative 20a, plus 25. So this is equal to 4 times 4a squared minus 20a plus 25, which gives me 16a squared, a minus 20a plus 100. Okay? And then this third one, I can actually take a function and plug it into the same function. That would be f of a. F of a. F of a. What is f of a? Well, that's 2a minus 5. So now I'm going to plug that in to itself. So I have a 2, and oh, look, I have an a. What do I plug in? I'm going to plug in 2a minus 5. And then I subtract 5. So I'm going to get 4a minus 10 minus 5, and that gives me 4a minus 15. That is f of a. So this has application. A lot of like double discounting works as a composite function. So Juan has $100 deducted from his check for retirement. He can have it deducted before or after state taxes. All right, and the state taxes are 25%. Sorry, 4%. Not sure where I got that from, but that's okay. It's 4%. All right. If Juan earns $1,500 per paycheck, what is the difference in his check? So we're looking for the difference between two numbers if he has the amount deducted before or after taxes. So if we do before, we start with his pay, which is $1,500. Okay? If we deduct it before, we deduct the retirement, that's minus 100. So that gives us $1,400. And then we deduct the state tax of 4%. So 4% of $1,400 is $56. So we're going to subtract $56, and that gives us $1,344. Okay? That's if he deducts it before he pays his taxes. What if he deducts it after he pays his taxes? Okay? So we're going to start with the same $1,500. Now he's going to pay his 4% tax. So minus the tax. 4% of $1,500 is $60. And so that gives us $1,440. And then we're going to deduct his retirement, which is $100. And so that gives us $1,340. So it's beneficial for him to deduct it before he pays his taxes, because then you're paying 4% of a smaller amount. So the difference is $4 more. The difference is $4. Okay, so this is the I think this is the last. Yep, this is the last one. So let's. Why don't you guys try this one as your video question, and then come back and I will work it out for you. All right. So we have this company called AutoX. They're offering an in-store rebate and a 15% on a particular digital audio player, and its selling price is $300. So it's asking us which is a better price, taking the discount before the rebate or taking the discount after the rebate. So let's calculate the before first. We start with $300, correct? Then we're taking the discount first, so then we're going to deduct off 15%, which is $45, which leaves us with $255. Then we're going to apply our rebate, which is $35, and that says that you're going to pay $220. Okay? Now if we did it after, or in the other order, we're still starting with $300, but now we're going to take the rebate off first. So minus the rebate, which is $35, and that's $265. And now we're going to take 15% of $265 minus 15%, which is $39.75. And then when you do that subtraction, you get $225.25. So it's better to take the 15% of the larger number of the original price and then apply the rebate. So it's better to discount before rebate, which is why stores will do it the other way. They'll rebate first and then they'll apply the discount because they're taking a percentage of a smaller number. So this is our daily assignment. We've done, at this point, you've done part of this assignment already, and now we're doing the composite function part. So I'll see you tomorrow. Thanks for listening.